Over the past couple of months, I've had a couple of emails questioning the approach of calibrating the panel meter. And it's covered in the manual, but it might be a little bit easier to show how it's done on a video. One thing we didn't cover in the intro video, this is a setup button and display button. It serves two functions. First of all, like the menu settings, first pick the menu of the item you're interested in either displaying information for or performing a setup operation on. So let me go ahead and pick P1, which is the internal panel meter. Display, which is a short push of this button, gives us information, general information on the calibration information that was used when this was set up. Crossneedle meter setting, number of scales 3. Forward power ranges are 20, 200, and 2000. Reverse power ranges are 5, 50, and 500. And you can see why this has 20 full scale and the reflected has 5. So the Dewa happens to have 20 and 4. There you would use different numbers. The way the Crossneedle meter works and the way that other nonlinear meters work, such as the MFJ, is as follows. You basically get to set the lowest range during setup, and the other two ranges go along for the ride, a factor of 10 and a factor of 100. In the case before, we had 20, 200, and 2000. For linear scale meters, which we won't show today, you can have 12 independent power ranges and 3 independent SWR ranges, and there are no restrictions. There is no coupling between the various ranges. You can set them to anything you want. You might have a very busy meter like we have some examples of on the web page, but you don't have any restrictions. Okay, let me continue to hit the display button. For multiple pages, the display button moves me through each page, and we showed yesterday that we use this to test or exit, and I'll just go ahead and exit. So that's the display function, and again, it applied to the panel meter. In this particular case, panel meter 1. Had I picked panel meter 3, which is the MFJ, and looked at the display information, that's classified as a nonlinear meter to differentiate it from a linear meter and a crossneedle meter. Again, it has that same rule. Number of power settings is 3. Number of SWR settings is 1 in this particular case. The SWR start value, there are situations where you might want to use a zero-based meter for SWR, and in that case, you can set the SWR starting value to 0. It's a little bit hokey, but without that capability, you'd never be able to use a zero-based meter of your own to display SWR. And in this case, again, the power ranges follow the times 10 and times 100 rule. Here I have a single SWR range set to 5, and I'm going to exit. Now let me go back to panel meter 1. What I'm going to do is erase the settings on this meter and calibrate the panel meter from scratch. To do that, again, I need to be on the panel meter menu. Long push puts me in the setup menu. This is very important. If you have multiple panel meters selected, the first thing it's asking is which port number, which panel meter. And again, this is designated as panel meter 1 or port 1. So you can go ahead, we saw yesterday that we have 3 meters defined, 1, 3, and 5. Make sure you pick the right number here before you go ahead and proceed and do something like erase settings. Otherwise, you may be erasing the settings for the wrong meter. Again, we know we want to deal with panel meter 1 here, so we have the right number. I use the select to proceed. It tells me previously set up, select action, and hit select. So it's giving me a warning that this is already calibrated. I'm going to hit menu button 2. These work the same way as the menu buttons on the bottom. They're positional. So that would be menu button 2. Settings erased. So this panel meter is gone. It's then asking me whether I want to calibrate a linear, nonlinear, or crossneedle meter. And in this particular case, again, positionally 1, 2, 3. I pick a crossneedle meter. Now, we talked about this soft overrange yesterday. The pots on the side have to be adjusted beyond full scale. Now, what I did here is I adjusted them until they hit the stop. There's no real possibility of damage here, but you have to go beyond the full scale when you adjust the pots. Otherwise, you won't be able to utilize the soft overrange feature. If you don't want to use it, no problem, but you should always go a little bit beyond full scale. Okay, so let's assume that we went through the process of adjusting the 2 needles, and in this case we have to adjust 2 pots, one for the for each needle. Again, I should point out that the crossneedle meter occupies two ports. That's why the next panel meter is designated 3. So we've done that. Both of our needles are past full scale deflection. I can hit any menu button to proceed. It's now prompting me with information. How many ranges do I want? And the information, the defaults here happen to be set up for this meter. I could set up 1 range, 2 ranges, 3 ranges. I might as well get the most flexibility out of it, but you can modify that if you want. We'll go ahead with the defaults on everything here. 3 ranges. Full scale power that I want to set up, again, this is controllable from 1 watt to 30,000 watts in 1 watt intervals. 20 is the right value here. If you had a 50 watt meter, that's the number you would use. So I'll select that. Select reflected power full scale range. Again, this shows full scale reading on the scale of 5. Could modify that if I wanted, but 5 happens to be the right number. Maximum overrange. That's the amount of extra current beyond what it calculates to drive to full scale that the meter will use when an overrange indication is present. If you don't want any overrange whatsoever, you can pick 0. 100% overrange, of course, you'll never drive the needle that far. It's just a question of how much current you'll drive. But typically, 5%, 10% is a good number. Something to get it beyond full scale and be noticeable. So let's go ahead and select that. Now it's questioning you as to the number of points you want to select for the forward power range. Now, this happens to be a linear scale, but the meter movement itself has a very slight amount of nonlinearity. We could have chosen 1 point and just calibrated this at the full scale value, but we chose 2 just to deal with the slight amount of nonlinearity it has. This can go anywhere from 1 point up to 50 points for highly nonlinear meters like the MFJ. We'll see that we need a little bit more, so let me go ahead and save. How many numbers do I want for reflected? The same thing in this particular case. And now it's asking me, do I want to set the tick marks with the pot or button? And you'll see how this works. I'm going to use the pot. You're going to use that most of the time. And it's just prompting me, okay, you're ready to start forward calibration. Hit any menu button. And now it prompts me for each point. Scale 1.01, use pot to set meter to 10. Okay. Let me go ahead and use the pot. Now what the trim is, let's assume, think of the trim as a nudge function. You probably won't need it in most cases, but if you wanted to bump this down a little bit or bump it up a little bit, that's what you'd use. In almost most cases you won't need it. It's now prompting me to set the second forward power value, and again that's as close as my eyes can set it to, and I'll use the save button. It's now prompting me that it's ready to enter the reflected mode. Okay, and it's telling me that I have to set the first reflected value to 2.5. and I'll hit the save button. And the second reflected power value to 5. I'll save all settings to EEPROM. And now it gives me a prompt, do you want to test this? And it's usually a good idea after the initial calibration to do a test. And it basically tells me what value I should expect. Each time I hit the next value, which corresponds to menu 1, okay, that should be at 10, that should be at 20, that should be at 0, that should be at 2.5, that should be at 5. Let's assume that one or more of those readings were off for whatever reason. You could then go back and use the edit function that we showed in the introductory video to tweak those readings that that were off. Okay, so we're basically ready to exit, and as we showed yesterday, if we go ahead and pick the sweep mode, and let me set the manual range. Okay, this basically should give us a nice sweep from 0 to 20 watts, 0 to 5 watts, and should follow the SWR curve all the way up. So that's an overview of the panel meter calibration for cross-needle meters. We'll now cover the MFJ meter, which is a little bit different, but you'll see some commonality as well. Okay, the challenge with a meter like this that has a nonlinear scale for power and a different nonlinear scale for SWR is to pick the number of points that you're going to use for each scale. And you pick those numbers for two different ways. First of all, depending upon the amount of nonlinearity, the more nonlinearity, the more points you need to do the piecewise approximation. The other thing you want to do is pick the number of points so that the settings don't drive you crazy during setup. For example, if I pick 20 points for the forward scale, I'll be prompted for 1 watt, 2 watts, 3 watts, etc. In fact, I think in this case here I'm going to actually pick 40 watts so that I can get down to 0.5 watts. Again, assuming that this is the 20 watt scale. This is going to be used for 20 watts, 200 watts, and 2000. But had I picked a number like 41, that would be workable, but it's going to give me numbers with strange decimal point values. Likewise, for the SWR, I can get pretty good granularity if I calibrate at each tenth, 1.1, 1.2, etc. Again, you just have to remember to subtract 1 from 5 because you're starting out in this particular case at 1. Let's go ahead and calibrate panel meter 3. I'm entering setup, and as I mentioned before, it's very important to make sure you've got the right number. In our case, we're going to modify port 3. It's telling us, again, in this case it's telling us the meter's not set up. I did an erase while the video was not filming. So I use edit whether I'm actually doing it in edit or a new calibration. So edit is the operation to use even for a new calibration. 1, 2, 3, 4. I'm going to pick the nonlinear choice. Linear is your standard linear scale meter. Crossneedle meter we've already discussed. So the second menu button is the one I want to choose. You can see the needle is already adjusted to go beyond full scale. It's going to now prompt me similar to what it did in the crossneedle meter. I'm going to select 3 ranges. I'm going to use 20, 200, and 2000. Full scale power of 20. Had this been 3,000 watts or 5,000 watts, I would be using 30 or 50 at this point. Number of SWR ranges 0 or 1. I can decide that maybe I want just a meter with power and no SWR. This particular meter face has an SWR scale, so we might as well calibrate it. Select the starting value. We'll pick a starting value of 1. As I mentioned before, the software will accommodate meters with that are 0 based, and the software will idle the needle at a 1, so that, again, you may have a very nice meter that you'd like to use for power, and there's also a scale on there that you might want to use for SWR, and because it's 0 based you wouldn't be able to use it otherwise had we not built that capability in. But in this case the SWR starts at 1, so 1, which is menu item 2, is the correct one to pick. Full scale SWR, I can pick any SWR from 2 to 50. In this particular case, my meter face has a full scale value SWR of 5, so that's what I'll use. This is the soft overrange that we talked about before. 5%, 10% does a good job. Number of points. I'm going to pick 40 points. That'll allow me to calibrate at the 0.5, 1 watt, 1.5, so I can get very good resolution. So let me go ahead and pick 40 points. It's now asking me how many points I want to use for the SWR scale. If I want to calibrate at 0.1 tick marks, I've got 10 tick marks per SWR unit, at least in the first area there that has the most granularity. So 10 per unit times 4 units will be 40, so I'll pick 40 points for the SWR as well. It's asking me whether I want to use a pot or button. I'll use the pot. It's telling me that forward calibration is about to begin, and it's now prompting me to start dialing in. Let me just see with the viewfinder if you can see that relatively closely. I'll zoom in a little bit more so that you can see the LCD and the meter. Okay, now I'm working to the side, so I'm probably building in a little parallax into these settings. It's now prompting me to dial in 1, prompting me to dial in 1.5. You get the point, and I won't promise not to to wear you out by going through all of these. So let me turn off the recording now, and we'll resume when we get ready for the SWR. Okay, I finished the forward calibration. It's now prompting me to start the SWR calibration. Again, just giving me an indicator that it's time to switch gears. Hit any menu button, and again, it's going to walk me through all 40 SWR points. Scale 2, that's what the SC2 stands for. Set 0.1 to 1.1. So again, I'm now calibrating the SWR scale on the bottom. .2. .3, 1.4, etc. So I'll do the rest offline and come back when I'm at the end of the SWR, and then we'll go through the calibration check like we did in the first video, just to make sure that everything got lined up properly. Okay, I'm near the end of the SWR calibration. It's prompting me for 4.9. In the areas where you don't have discrete tick marks, you have to have a reasonably good eye and use your judgment. The last SWR value is 5. It wants to know if I want to save all settings. Okay, in those calibration settings are saved. Okay, calibration is finished. It's now asking me if I want to test or exit. So let's pick the test. And again, like we showed in the first video, it's going to walk us through all 40 points. And it'll tell us what we should expect to see at each point. 0.5, 1, 1.5, 2, 2.5, 3. And I definitely did introduce some parallax because I was sitting from the side. But let me just move all the way up to, you can see that between 19 and 20, 19.5, it does a pretty good job of retaining the settings that you set up during calibration. Okay, now it's ready to walk through the SWR calibrations so that we can check those. 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7. Okay, and again, once I'm in this range here, I had to do some interpolation, but 4, 4.1, 4.2, all the way up to 4.9 and 5. So that looks pretty good too. Okay, I'm going to set this up so that we can actually measure some real power on it and see how this works in the real world.